Hello and welcome to a new chapter of Azure Support Academy HANA Lab series. In this episode number 6, we are going to talk about a common issue that we have in terms of connectivity. TCP Provider, the Semaphore Timeout period had expired. My name is Jose Manuel Jurado. I'm an escalation engineer working in Microsoft and subject matter expert in this technology.
Hi everyone, my name is Dineo Assis and I'm the support escalation engineer here at Microsoft in SQL Networking team. I'm also a developer in our SQL Networking GitHub, developing internal and external tools to support the community. And because my previous experience was more focused on business intelligence, I'm also a Master of Science in that matter. You'll find my contacts below in this slide, and I'm looking forward to hearing from you all soon. Thank you. In this episode, we will talk about the problem Semaphore Timeout, which mainly occurs when you are having a data transfer between one or more sources targeting one specific server. Why does it happen? Basically, the application gives up on waiting for the results from the target server. So there is a data transfer happening, and at some point, this information flow stops, and the application gives up on waiting for the next results. How to find it? Usually you find this error in application logs, and they are mainly followed by the client driver names or protocols, such as OLDB or TCP. In the way that we decided to put in the title of this session, you will see, for example, TCP Provider, the Semaphore Timeout period has expired. And basically, to fix this, you need to either look for network blockers, such as firewall, some unusual behavior from a network appliance, like a load balancer, for example. But you can also find the issue and fix it if the problem occurred because of the performance of the target server. Let's say you have a poor performance happening on the target side, and then because of that, the client decided to give up on waiting for results. All right, I think we are live. Okay, first of all, thank you for joining this session and watching these episodes. This is an initiative from Jose Manuel, and I'm really thankful for receiving the invite to talk a little bit about the Semaphore Timeout. So we will try to do this session like a video cast. So I have Jose connected here in this session with me, and we are going to talk about the problem, the situation that may lead to reach the failures, and what could be the cause, and most important, how or what should we look for to troubleshoot and resolve the issue. Okay, so just for you guys to know, we are talking about the Semaphore Timeout, which basically means that so in a Semaphore Timeout, I'll try to explain like this. We have more than one source involved. So let's say if this box is a source, we have another box that is the destination. And I have here a client box copying data from this box to this one. So the data flow flows into this direction. And then the same box connects to another target server and will push the data into that target server. So let's say this is the source. Call this as a source. Let's say this is the destination and this is the client. So just to pay attention that the source can be inside the client. So you could have two boxes only in this schema, representation schema. We are doing with three boxes to make it easier to explain. So what happens here is this process will work in a batch. It will follow some batches. So the data will be transferred from the source to the client. So we will see this happening in chunks, right? So the files will be split into smaller pieces, and then the data will be split into smaller packets and then transferred to the client. And at the same time, they will be uploaded to the destination. And if there is any problem in between this communication, let's say a network device in between these two nodes that stopped responding, or a performance condition on the destination side, anything that can interrupt or can cause impact during this data transfer can lead us to the Semaphore timeout. So in the end, the Semaphore timeout can be summarized as the client gave up on waiting to continue sending the data. So it was waiting for some time, and then at some point, it decided to give up and stop the process. And then the applications usually they raise the Semaphore timeout error message. So what I did here to explain is exactly what we saw in the paintbrush. I have here an integration services packet where I'm bringing data from one source and uploading that data to a destination. So just letting you know, so I have this is the destination, SQL A01 VM2, and the target, the source is SQL A01 VM1. So they are all in the same domain. I will show you guys first how the transfer will happen in trying to target more than one perspective, which is I'm going to start here a network trace. Let me see. Okay, so we have this network trace. I'm going to start it right now. And because I know my target servers, they are running in the port 1433, I will add them here. So it looks like there is a connection already established between the nodes. Probably because I have a SQL Server installed also on this box, and there is a linked server to them as well. So let's leave the Wireshark capturing the data while we start the transfer. So just to show to you how the transfer is supposed to work and how we will be following the progress of this package. So there is no issue right now. We don't have any problems here. So you will see packets are flowing from the source 4.0.6, and actually the source is 12, and the destination is the 10.4.0.6. So we'll see here the data. I'm selecting data from one table and sending the data to the destination. So now just to confirm, so my destination is the SQL A01 VM2. And okay, so this is the IP address. What I will do now is I will open a remote desktop connection to SQL A01 VM2. The process is still loading, so we are still moving the data from one side to another. And let me, Okay, now this is the SQL AO1 VM2. Let's hope it starts. Okay, maybe this is putting too more pressure in the server. That's why it's not loading, or not. Okay, it is still loading.
Dinu, and then, if I understood correctly, you mentioned that Semaphore Timeout is when one part of the client is not receiving the reply from the destination. In this case, because you mentioned source, client, destinations. So what that's mean? Meanwhile, it's loading the servers. What that's mean? This Semaphore Timeout in this case. I need.
All right. So in this case, we are pulling data from the server, and we are pushing data to the. We are downloading data from this source, and we are uploading the data to this destination. So if we have any connectivity issue, let's say a device here in between that start blocking the frames for any reason, or also a filter driver, like it's pretty much common to have antiviruses. They have access to the data before any other application. So let's say there is an antivirus scanning the information here on the destination, and then this is causing some impact because it is slowing down the process where the client here, this box, is expecting to perform a complete transfer between the source and the destination, right? So I'm still moving data here. So if any of these partners, they stop responding, we will see this box that you are also seeing in this transmission. This box will still we'll still try to upload this information to the destination. So we shall see retransmits, or if not, we shall see keep alives, meaning that in the network traces, meaning that this guy, the main guy here, the main client, is waiting for the other side to send some information. And it will keep waiting for quite a long time until it gives up. So it's usually a common timeout, right? So the first, the property that can be configured in the applications that are related in this communication is the common timeout. So when the common timeout triggers, what we will have is a Semaphore timeout expired because I have two operations on the way. Like I'm selecting data, I'm storing data locally in this box, and then I'm sending the data to the destination. So the integration services, the package here, it will all the time keep looking for the data at the source and sending the data to the destination. If any of these operations stop for any reason, we'll find a Semaphore timeout. So this is what we are going to introduce right now. What I'm going to do here is I open a connection to the destination, and this is for educational process. So normally in a normal transmission, you should never find this error, but when it happens, it's because you have a malfunctioning, for example, network appliance in between the destination and the source. So what I will do here is I'm opening the firewall in the destination, and I have here an inbound rule that I created previously. And what this inbound rule will do is it will block. Let me just see. I think I had this. Was it? Yeah, actually, it's the outbound. Let's see. No, it was the inbound, but I don't see here.
I saw SQL TCP. What's probably perhaps another rule that you have.
Yeah, but I created one to
Okay.
to block specifically this connection. Here it is. So yes,
Okay.
it's the inbound rule. So I'm blocking. I apologize for because I tested with both, and in the end I forgot to remove that outbound. So we have this inbound rule, which means I'm going to block any traffic received from this IP address here, 10.4.0.12. Okay. And what is 10.4.0.12? Is our client box on the other side. So here, just maybe to make it easy to explain, our source where we are getting data from is this one. So 10.4.0.5. Our destination is this one, 10.4.0.6. And our machine where we have the IPv4, where we have the package running, is the 12. So I'm blocking all the traffic now that is originated from this box here on the remote server. Let me just, yeah, here it is. So as soon as I do this, I'm afraid that I will lose the connection to this box because my RDP also comes from it. So anyway, I'm going to enable this rule. And you see the connection was already lost. So I'm not connected to that box again. This connection will fail. And now our process also is hanging here. So it's waiting for the data. You see the rows counting, they have stopped. And in the network traces, you will start seeing keep alives. So my box, the source, sending messages to the destination and not receiving any response. At some point, the process is canceled. So you see, as soon as I block the traffic, I now have here an icon indicating that the process has stopped. And when I go to check the error messages, so if we check the error message here, you will see that as soon as I copy this text, let's just, where is my notepad? All right. So here I copy the error message from the SSIS package, and here we see a transport level error occurred when receiving the results from the server, and the Semaphore timeout period has expired. So now we have here the traces collected. So usually, if you have a network capture at the time when you are reproducing the issue, one thing that you can do is to look for resets. So I'm filtering here the TCP port or SQL Server, and I'm going to filter also the flags reset. And here we are. So we had a reset that was sent from my box to that destination, and we never received a response from that reset. So this concludes, this explains actually why the application decided to close, to give up on waiting for a response of the server. Okay, so just to show you again the keep alives, if I remove the filter and go, now I'm receiving the error message from the remote desktop connection because I added that rule that is denying, is blocking all the traffic generated from this server where I am. Okay, so now if I remove the reset and then jump to that frame number here, 108903. Here it is. Here we see what were the messages, what was the behavior before disconnecting. So we have the time here described in seconds. You will see keep alives being sent every second. So 592, 593, so forth, so far and so forth, until we reach 10 keep alives, and this means that the application will not wait for the other side to respond to any other frame anymore, and we are going to close this connection. So that's why a reset is sent from the client to the target. And we have so when I say client here, we are talking about different perspectives, right? So my SSIS is the client, and we have a source and we have the destination. So this client here, this is my client 10.4.0.12, sent a reset to the destination 10.4.0.6. And because it did not receive any message, any response from the destination, it decided to close the call and sent this reset right after the 10 keep alives. So this is the behavior in the network. And what are the reasons for this? In our case here, it was pretty clear that it was a network condition. So we added a blocker in between the client and the server. But it could be any other, it could be some other, we could have some other explanation for the same problem, like an antivirus. If we had an antivirus installed in this box here, that antivirus could be blocking the communication, the frames that were originated from the other side. So it's not that every antivirus do this. It's not that, this is not what I'm saying. What I'm saying is that filter drivers are known for causing interruption in the communication because they have access to the data before any other application. So it might be interesting to remove the antivirus for testing purposes only. And once you conclude that without the antivirus, the problem does not occur, you can discuss with the vendor behind that solution to understand why is it blocking. We know that for antivirus, we have also the standard exceptions, right? That can be configured to avoid analyzing the traffic from the network, for example. And one more thing that can happen is performance on, in this case, performance on the target side. So on my target side, I have a SQL Server running on a virtual machine. But it could be a SQL Server running in a platform or any other data source running in a different platform. So you could check, also look for performance issues on that server to understand if there could be any blockings, anything that could lead the destination to become unresponsive, like we have in this example. And I think we covered everything. This is what I had planned for this session. Would you have any questions, Jose, for now?
Yes. Could you please explain a little bit what that's being keep alive? Because this is my first question. What that's mean? This is just only, yeah, it's just only to let's say to request if the destination is alive, right, or something like this, right?
Yeah, exactly. So the whole communication goes into the TCP layer. So TCP is a protocol that requires confirmation. So every message is sent, that is sent from an origin, needs to be confirmed from the target as soon as the target receives the message. So if there is no communication between the nodes, we will see the client, the one who started the communication, it will start sending keep alives, which they are more like we can compare keep alives like if they were ping commands, you know, ping packets. We are pinging the other side to see if it's responding. Because it could be busy. In this case, the SQL Server could be busy inserting the data that I was sending to it by this package here. It could be busy in a way that it was not communicating with the client anymore. So in that sense, the network card would reply the keep alives with a keep alive ACK, meaning that, okay, I got your keep alive, I'm here, I'm still working, but please wait. And it's not what we see here, right? So we see the keep alives, they were sent, and we didn't receive any response from the other side. Is that clear?
Yep. Mm-hmm. Yeah. Just other question that I have. It's when right now it's the issue that we have is when transferring data and we enable the firewall in order to prevent any connections or any connections from the client, the IP that's finishing by 12. But it could be happen that when we try to connect to the server, so at the beginning of the connection, could it be possible that we could have this semaphore timeout, or is just only when we send the data?
No, it could happen at any moment. It doesn't need to happen when the connection is already established. However, the connection process may be a little bit more complex. Just opening a parenthesis here. So when we talk about the connection, so connection to SQL Server, for example, you have some steps that are performed, and if the connection fails in between those steps, we may find different error messages. Okay, for example, I would just try to simplify here. We have the TCP Handshake, which can be found here. Let me filter the scene, flags.scene. I think we do. Okay, so we have this. Let's filter this TCP. So we have all the scene frames. Let's filter now the frames 5198. Okay, so this is the very beginning of the connection, and these three frames here, they represent the TCP handshake. You see 3 frames. The client sends a sync, the server acknowledges that sync, and the client sends an ACK acknowledging this guy here. So because of that, we have the TCP handshake established. Then after it, you have the TLS handshake that is represented by the set of 6 messages that we see here, plus the encryption. So when the data start, at some point of the TLS handshake, the client will send either the credentials or Kerberos tickets. It depends on what is the authentication method. It will send some information encrypted, and then we'll start seeing responses from queries. For example, here, when the connection is just concluded, you may find maybe it's here we have an error message that actually is an information saying change a database context to test target. So I was moving the default database to this, so my context was changed to this database, and next to it we start seeing some queries. So from this point here, from this response until the end of the communication, if the traffic is blocked, we will pretty much like see a connection, a semaphore timeout. But before that, if the communication gets interrupted before that response, before the change database context, and again, this I'm talking about a SQL Server on-premise, but we have a very similar, pretty much similar process in the Azure SQL DB. And so if the process is interrupted before this response, the error messages may change. You can get here a connection was established, but then some issue occurred during the pre-login TLS handshake, for example. Or here you would get in the very beginning during the TCP handshake, you would get unable to open a connection to SQL Server. So not all of them will refer to a Semaphore Timeout. I was writing here the steps. Let me just so we have the TCP, we have the TLS handshake, and after that you start seeing queries. So queries, commands, and so on. So from this, when the TLS handshake is completed, so the user is authenticated and logged into the SQL Server. From that moment on, we can get a Semaphore Timeout. But before that, we shall see some different error messages. Is that clear?
Yes, it's clear. No, it's very important because it's when we have some cases in terms of depending on their message, it's just only to clarify the situation. Just only another question that I have. It's clear that when we have encrypted the data and like we're using SQL Azure database and managed instance, we are not going to see the text that we are interchanging between the servers. And just only one clarification more about, if you please go to the white chart again. We know that all the connection is using 1433. What does mean that the client is using 50, the port 5018? What does mean this?
Okay, so we are establishing a TCP connection between this client and the destination. The port on the destination is 1433, but TCP, it's a channel, it's a communication channel. So it needs to leave from one box, from one port in this box. And the process, they will take a port in the range that it's called ephemeral ports. So ephemeral ports is a range of ports that starts around, I think, 50. We have a documentation for that, from 15,000 to 64,000. So any port that is seen during this range, so from 50 to 64, is known as an ephemeral port. We can even increase this range, but in fact, what we have is a TCP channel will be established between this client and this destination, and we need to have an identifier for this client. And the client will use a port from an ephemeral range, and the destination will always use the port that is configured on SQL Server to be listening. The port that SQL Server is using to listen. So yeah, and there are some ways to extend this ephemeral port. Let's say if you have a server that needs to open more than 15,000 connections, simultaneous 15,000 connections, and this is this range here. They cover all the TCP layers, so all the TCP connections. So we could be talking about a web server, for example, that will have many connections established to run HTTP services, and then you may run out of ports to create connections to SQL Server. But this would lead you to other different error messages as well.
Okay. No, thank you so much. It's very important. It's very important. So at the end, basically, the outbound connection. If I have, let's say, in my environment, the outbound connection will be 1433, basically. Okay, because the ephemeral port is open in the client, not in the server. Let's say when the destination, when I want to connect, basically it's just only the port 1433.
You're right, right. Yeah,
Okay.
we target the port 143, but
Okay.
the client will use a port from that ephemeral ports range, and in order to be able, so it's a channel, and the channel should have an identifier at the very beginning and at the very end. So that's why here you see the source is using this first port and the destination is using this second port. And in the Wireshark, we can see it clearly. For example, when the server replies, you see the server now, the .0.6 from the port 1433 is replying the data to the source for .0.12 on the port 5198.
Okay.
Okay. Would you have any questions?
No. So basically, if I understood correctly, a Semaphore timeout is when you are sending some data and you are waiting for the reply, and the reply never, let's say, never reaches to us again.
Yeah.
And we send some keep alive. Let's say, okay, you are alive, you are alive, you are alive, and say, okay, there is not possible to reach again the server, and we are going to run this Semaphore timeout, right? If I understood correctly.
Exactly. Perfectly.
Okay. Okay. Perfect. Thank you so much, Daniel.
All
It was
right. You're welcome. Thank you so much. Also, the audience for watching this video. We hope it brings you some clarity on how the semaphore timeout happens, and hope we can help you solve any issues if you find it. Okay, thank you so much. I think we are good to close this call. Thanks again, Jose, for the invitation, and let's see you in the next one.
Thank you so much, Daniel.
Thank you. Bye bye.
Okay, thank you so much for attending these sessions. If you have any questions, please send an email to gmjurado@microsoft.com.